Hey everybody, it's Jim Kemp with 705 CNC. Hey, I got this crazy job from a customer making these plates. The problem is, as you can probably tell, I need to drill and tap some holes along the edge, and that's just not going to happen. This is a VF5, which is pretty large, but there's just no way I'm going to get this underneath the spindle. So, you know, what's a poor boy to do? Just to be clear, this thing is, what I've got to cut is 32.5 inches tall, and the spindle, let me get this out of the way, is like maybe 28 inches comfortably, and that's with the spindle all the way up. So yeah, there's just no way to be able to get up over the top of this thing. So yeah, we got to come up with something else. So this is the answer. Mount this thing on our vacuum plate. So just hang the plate over the edge of the table. The spindle goes about 1 inch past the edge of the table. That's about the max Y travel. So I don't know if Haas designed it that way, but so we're hanging, let's see how much we got here. We're hanging just over 11 inches over the table. That's about the maximum. So this thing just barely clears the way cover. But that gets it down low enough that we can then drill and tap the top edge of this plate. So that was the answer. And this thing being held on with vacuum, it is not coming off. I did the math. This is like 7.5 by 9.5 is the area. You multiply those two together by 14, you come up with, there's 1,000 pounds of force. So half a ton is pressing this plate onto the vacuum plate. So not coming off. So that's the answer. I haven't seen this done before. You know, hanging stuff over the edge of the table so that you can get more height underneath the spindle. But for this particular job, that really worked out. You know, of course, you're trying to use the equipment that you have. You know, for sure you could have sent it out to somebody that has a horizontal or boring machine, whatever. But you know, all I had to do is mount this thing on here, and Bob's your uncle. So yeah, a quick video. But let me show you the vac clamp next. Forgot about that. This is what that vacuum plate looks like with the part removed. You can see, you know, this is the area that we're using right now. But you know, there's multiple tracks in this thing, so you can put the rubber for, you know, and then we'll just carve new tracks in here for different size parts. But yeah, that's just hanging right over the edge, just over the edge, so you can hang anything over to machine it. But that was pretty cool. Nice little tip of the day. Of course, this is our vacuum controller that we sell on Shopify. So if you go to vacclamp.com, you can buy one of these for a few bucks. But this is what keeps the vacuum pump turned on and off. So I made a bunch of videos on this already, so you can look in some of the other ones if you want to see a bunch of details on this thing. But yeah, you just set the two set points and it keeps the vacuum going. But when you have a good system that doesn't leak, the vacuum pump doesn't run, which is nice. And here's the relay box for that thing. So you see the giant relay inside there that turns the pump on and off. There's the actual vacuum sensor right there. A couple other little small relays. So, and then that turns the pump on back here. There's the actual vacuum pump with a little pressure pot. So yeah, that's kind of the system in a nutshell. I thought this was pretty cool. This is our typical setup. So we've got both vacuum plates bolted down here, and I just went around with a probe, set this as 0. This is -4/10, -2/10, -14/10. That's worse. -4/10, 0, +1, -3, -9, -1. So for whatever reason, these two corners are low relative to this being 0. But anyway, I just thought this was pretty cool because you got, just did the math. This is 9.5 by 22. If we ignore these two cutouts and notches, between the two plates, it's over 5,000 pounds of downward pressure holding the part down. So let me throw the plate back on here. We'll get facing this thing again, and you can see how cool this is. Been harsh. Got a leak.
No, that ain't so.
Got it all trimmed in. Let's see if it holds down. I'll wipe everything down. Because having a leak sucks.
Yeah. On a nice machine surface?
It looks like it's holding now. This is your first cameo, by the way.
What's that?
We're recording.
Hi. This is awesome.
So, yeah. And it all trimmed in, all set to go. And then there's a leak. I don't know.
Well, that sucks.
So that sucked. So, pull it off, clean everything up, try again. And now it seems to be, yeah,
It's holding now?
holding now. Hold
So-
all day. 5,000 pounds of pressure. Now
Nice. Nice.
This thing turned out just absolutely beautiful. Just can't feel anything. This is just perfect. It's a big old 4-inch shell mill. And the entire time, we never lost any vacuum at all. It just stayed right there. I think it'll take a couple hours before that thing would come back on. It's amazing. I think I'm just gonna leave the vacuum pump on over the weekend. Come back in, it'll just be stuck right where I left it. Crazy.